Hi, and welcome to this video on system administration concepts. So in this video, we're going to look at what systems administration is about, the job description of a systems administrator, some data center architectures as well as what data centers are all about, and some common terms that are used by system administrators when they're doing their work. So what is systems administration? Basically, systems administration is about managing one or more systems, be they software or hardware, in making sure that they are working and running efficiently and effectively. So systems administration is just about making sure that the computers or the servers or the softwares of an organization are delivering the value that they're supposed to deliver, they are running, and they are doing their work effectively. And the duties of a systems administrator now, they are very wide and they are very varied. It depends on the organization that you're working for, and it depends on what needs to be done. But basically, it encompasses around the policies as well as the configurations of computer systems in an organization. So a systems administrator is expected to monitor systems health. By health, we mean, is it working fine? Are the logs being logged well, or are they not using up too much space? A systems administrator is also supposed to look at system resources like disk space, like memory, like CPU, to make sure that we are not either underusing or overusing the resources. So for example, an organization can set a threshold of 75% and say if CPU usage is about 75%, is above 75%, then there's need for us to add more resources. If it's below 25%, then we need to remove these resources and the like. The systems administrator also performs backups and manages user access as well as user accounts. And backups are some of the most important things in a system administrator's jobs, because in the event that there's a problem with the system, they should be able to recover it by taking the backups. The systems administrator also monitors systems its security, and security has really become a topical issue in today's world, given that everybody is now using computer systems as well as everybody is now connected to the internet. You're also expected to install new hardware and maintain computer systems like servers and databases. So you should have knowledge of servers, knowledge of databases, knowledge of how to put new hardware and software in a data center or on a specific computer. Then on top of that, you're supposed to respond to system outages. So basically, a systems administrator, this is where they show their expertise. When there is a system problem, they're the ones who are supposed to respond to the problem and solve those problems. Then you're also expected in doing your work as well as in solving some challenges to do some light scripting. For example, creating Python scripts that can help you to either automate some of your tasks or to improve your workflow as you do your work. And then the systems administrator, being the guy who knows a lot about the IT systems of an organization or IT in general, is also expected to provide recommendations to the organizations on varying IT issues. They're also expected to know issues to do with networks, and they are also responsible for recommending how organizational policies concerning IT systems are to be crafted. On top of that, they advise senior managers on the best practices for computer networks as well as for computer systems, and they frequently and usually have the power for buying equipment, setting budgets, and for deciding what it is that has to be bought. So basically, this is what a systems administrator is supposed to do. They're supposed to monitor systems, adhere to policies, craft those policies, and make recommendations on IT solutions. Now, a systems administrator is more likely to be found working in data centers. So a data center is basically a building that houses computer systems at a large scale. So these computer systems could be serving one company, or they could be serving multiple companies. These days, we now have private clouds where one company can actually have its own data center, or public clouds where these are data centers that are serving various people. So in these data centers, you'll find there's a lot of stuff that's required. You require cooling for cooling the various servers in there. You require networking. You require the servers themselves. These are rack-mounted servers. So you find that the servers are mounted on racks, which are basically tall steel structures or cases where you then slide in the rectangular servers in there, and then you have multiple of them. So this is more like a pod, a modular data center. Inside there are these racks, and in these racks there are these various servers. So the servers can come in different shapes but usually their sizes are more or less the same. There could be 1U or 2U in size. And then this picture shows how a building with a data center would look. So here are the offices. Here are the offices for the systems administrators. This could be UPS systems. In case there's a power outage, the UPS will make sure the systems run for probably some time, which could be 15 to 30 minutes until the backup power kicks in. And these are the various racks that contain the servers as well as the networking. So these data centers, in order to function well, they've got various architectures. One could be an active architecture, where you could have both data centers handling traffic at the same time. That way, if one data center goes down, the other one continues to handle traffic, and in such a case, there is no downtime. And then there could be an active standby, where you've got one data center that is on standby, while the other one is actually handling live traffic. So if there's an outage in the data center handling live traffic, then we can manually or automatically route the traffic to the secondary data center. So what are some of the common terms that are associated with systems administration? Systems administration is concerned with system uptime. By system uptime, we mean how long the system has been running uninterrupted for a given period. So we could say for the past quarter, for the past 3 months, how long has the system run without any interruptions? So out of 3 months, we could say it has run 99% of the time without any problems. And uptime is more or less related to availability, where the system is available to the customer. So uptime measures how long the system has been up in a given period, and it's usually in a percentage, whereas downtime measures how long the system has been down in a given period. So if the uptime for the past 3 months was 99%, then naturally we would assume the downtime was 1%. So the system was running non-stop for 99% of the time, and it had interruptions or downtime of 1%. Then availability means, is the system available for the customers or for its users to use it? That's availability. So uptime could be how long the system was up. Availability is now looking at if the actual users of the system were able to use the system. But you'll find that availability and uptime may actually be related in one way or the other. Then there's capacity utilization. Systems administrators look at how much capacity is required by a server or is being used by a server. So a server could have 800 gig and 32 gigabytes of storage. 32 gigabytes of memory, 800 gig of storage, as well as maybe 4 virtual CPUs. So the systems administrator is now responsible for making sure that each server has got the right number of CPUs, right number of memory, and right number of storage for it to deliver the quality of service that is required by the customers. Now, for you to make sure that you are actually delivering good service, you need to be monitoring those systems. So one of the ways of monitoring the systems is by having what are called NOC, or Network Operations Center. So a Network Operations Center is a place where there are people who are just looking at various tools and metrics to see if we are still getting the quality of service that we require from systems. For example, one of the tools that could be used could be the Manage Engine Applications Manager, which is a system that is used to monitor other systems if they are up. So this system can use a ping-based approach where it's continually pinging the other system to check if it's up. If it does not receive any ping back, then it means that system is down, and therefore it creates an alert, and the alert is received by the person monitoring the systems, and the person alerts the system administrators at various levels of support. Could be level 1, level 2, or level 3. So these tools could be monitoring for availability, which is the ping-based approach, be checking if the system is actually up and running, or it could be also capacity monitoring to see if there's any system that has breached the threshold. Let's say we set a threshold of 70%. If more than 70% of the CPU is now being used, then the system will generate an alert and notify the systems administrator that there may be need to either check the system or to add more resources to this system. Then in dealing with these systems, in making sure that the uptime of those systems is good, there is something called high availability as well as disaster recovery. So high availability is about trying by all means to eliminate downtime. So with high availability, basically the aim is to have 100% uptime for a given system in a given period. So for high availability, that's where you can end up having an active approach where you have two servers running the same application and you're having a load balancer that distributes the traffic that comes to those servers between those various servers. So this one could involve clustering, it could involve automatic failover, and it could also involve mirroring to make sure that at any one time we have more than one system doing the same thing, so that if one goes down, the other one keeps on working while the other one is also being fixed. So that's about high availability. Then disaster recovery is about making sure that in the event of a disaster, we can be able to recover our IT systems as a business. The period of time of recovery may differ depending on what we want to achieve, but we could say we want to recover in a period of 10 hours, 20 hours, 2 days, 1 week, depending on the business. And that's where issues to do with recovery time objective come into play. So recovery time objective means how long should a system be down before it comes up again. So when we are talking of the recovery time objective, or RTO, we are talking of the amount of time that we can tolerate the system not working. So this is the amount of time that we can actually say the system has not been working for the past 2 hours. Is that okay or not for us? So basically this is just the amount of time that we can tolerate and not ask any questions if the system is down. So if the system is down for 1 hour when our RTO is 2 hours, then we are still okay because it's within the recovery time that we have set for ourselves. But if the system now goes down for 4 hours when our recovery time objective is 2 hours, then we have a problem because the system has now breached the amount of time that we can tolerate a downtime. Then recovery point objective is looking at how much data or how much data loss we can tolerate. So let's say we've got a database that goes down, and when we recover that database, how much data can we afford to lose in terms of maybe time? So we could say data of the past 5 minutes can be lost without any problem. So if the system went down at 11 p.m., then we would say any data between 10:55 and 11 p.m. 10:55 p.m. and 11 p.m. can be lost without any problem because our recovery point objective is 5 minutes. So we are saying we can lose 5 minutes worth of data and not raise an issue about it. But if we lose more, then we need to investigate and make sure that we can find out why we lose so much data. And then we could also set a recovery point objective of 2 days to say, you know what, if our business is not so critical, we don't get clients every day. So if we lose data worth of 2 days, of the past 2 days, then we wouldn't have lost much. So that's our recovery point objective. If we lose 2 days of data, we are not going to panic. But if we lose more, then we're going to have a problem. So when you have a disaster now, how do you recover from that disaster? So what you do is you either use your backups. So you are always doing backups, and you're encouraged to do off-site backups so that your backups are not in the same place as your live systems. That way you have got an assurance that if the site where the live systems either is destroyed by fire, floods, bombs, whatever, you can still get your backups from another site. You could also use asynchronous mirroring and log shipping to back up your systems so that you can recover, as well as to have standby data centers so that in the event of a disaster in one location, the other system in the other location can keep running. So that's all about systems administration, and I hope you've learned a lot from this. Thank you.